Hi guys, in this video we're going to look at factorizing. Factorizing is the reverse of expanding. This time we're going to be writing our expressions into brackets. And so there's a few steps that we follow to do that. We need to look at all of our terms that are separated by a plus or a minus, and we need to look for anything that each side have in common. Okay, that's what we're going to factor out, and factoring out is essentially dividing out. So we're going to look for the highest common factor that gets put in front of the brackets. So does any common variable that you might find on either side. And then what's left inside the brackets is the results of any of those divisions with the numbers and any letters that you can't remove. And the key thing is that you need to make sure that there are no common factors left. Okay, whenever you're asked to factorize, they're missing out a little word that they imply, which is factorize fully. So here, let's look at this first example. We have 3a plus 3b. So we've got a common factor with the numbers, so we can divide both of these terms by 3. So when we divide by 3, it's going to cancel out the 3. We're going to get a 1 on the inside of the brackets. On the outside of our brackets is that 3 that we've divided out. Now, we've got an a and b as well. They're unlike terms, and so we're just going to have to leave them as they are. We can't divide out an a from both sides. We can't divide out a b from both sides. So we're left with that a plus b inside the brackets. And just to double check, to make sure we get back to where we were, we can just expand it out again. We get 3a and then plus 3b, and we're back to the start. So we've done it right. Now, you don't necessarily always need to double check it, although if you're unsure, it's a great way. It's not too hard to do. It's a great way to check it. Okay, this time we have a negative, but otherwise it looks very similar to the first one. We have a 10 on this side, a 10 on that side, and so we can divide out a 10 on both sides. We have an x and a y. Those are unlike terms, so we're not going to be able to take out any x's or any y's there. So 10 goes on the outside of my brackets, and what am I left with if I divide this by 10? I'm left with just an x, and then I'm left with a negative y in this instance because we have a negative 10 here, negative 10y here. Okay, let's have a look at this third one here. So this time we've got a 3 and a 5. They're both prime numbers. They're not going to have any common factors that we can divide out. But we do have two common letters, two common variables. So we can actually divide out. Now I'm just showing you this division, but you don't actually need to show this in your working. But just to remind you what we're doing here, we're actually dividing out a c. That c now goes on the outside of the brackets. And so these c's on both sides are going to be cancelled out. And we're left with a 3 plus 5. And again, let's just double check this one. C times 3 is 3c. And c times 5 is 5c, and we've got that one right. Okay, this time we have two different numbers, but they both have a highest common factor of 5. Okay, we can divide 5 on both of these sides. Again, you don't usually need to show this working, but I just like to do it just to show you how it works. So we divide out a 5, which means it goes in the front of our brackets. This will cancel out to 1, so now we just have 1x on this side, and over here we get plus 2. We have 2 5s and 10, and it's a 2y. The x and the y stay there because we can't divide out either of those from both. And let's just quickly double check this one. We have 5x plus 10y, and we're back to where we were, so that one's right. Okay, this one here, it's only got a variable on one side, but it's still the same rules that apply. Now I'm going to show you here what happens when you don't divide out the highest common factor, because we know that the highest common factor of 4 and 8 is 4. But perhaps you've got a pair of numbers that you're not quite sure of, but you know that they're both even, so you could halve both of them. So let's do that instead. Instead of factoring out a 4 on both sides, I'm only going to factor out a 2 on both sides. So I'm going to put a 2 on the outside of my brackets. On the inside of my brackets, if I divide 4 by 2, I'm left with 2v. And if I divide 8 by 2, I've got plus 4. Okay, so I have factorized this. It is now put into brackets, but I haven't factorized it fully. There is still a common factor in both of these terms. Okay, there's a 2 in here and there's two 2's here. So I could, if I was unsure before, if I want to just keep following this method, well, I could, of course, divide out that 2 again on this side, So now this 2, remember I'm dividing it out so it becomes a multiplier in the front here. So now I'm going to have 2 times 2 in front of the brackets, and then I'm going to have a v plus 2. Now 2 times 2, of course, is the same as saying 4v plus 2. And I've got no common factors left inside my bracket, so I've factorized fully. So you can get to that fully factorized form if you're unsure of a highest common factor by continuing to divide out numbers. However, it's of course easiest if you know that highest common factor here is going to be 4 to skip straight to using that 4. Alright, this one over here we have a 3x squared plus x. Now there's no numbers on both sides, there's only a number here, so I'm not going to be able to divide out the 3. However, I've got x's on both sides. I have an x squared here, which is an x times x, and I have an x here, which is an x to the power of 1, just an x by itself, which means I can actually take out one of those x's that are getting multiplied here, and I can take out this x here. So I'm going to divide both of these by x. So on the outside of my brackets, I have an x, because that's the highest power that's on both of them, is an x to the power of 1. So if I take out 1 here, then I'm going to be left with 1 there, aren't I? So I'm going to have 3x. And here, if I divide x by x, anything over itself is 1. Okay? So if you ever divide out everything, factor out everything in one of your terms, then you're always still left with 1. Okay, and it's important that we do that, because let's expand this again. So x times 3x is 3x squared, and x times positive 1 is plus x. And we're back to where we started. If I had divided out that x and treated it as a 0, like it was completely cancelled out, then all I would have had in my final answer once I expanded again was 3x squared, and that x would have been gone. So we've got to remember, when we cancel out our terms, we've still got a 1 left over. Alright, let's look at this one here. We have 2xy plus 2xz. Now I've got a common number and a common letter here that I can factor out. So I'm going to divide both of these sides by 2x. So I've got a 2x on the outside of my brackets, and all that's left over after I divide out a 2x on both sides is a y plus z. And again, let's just double check our answer. 2x times y is 2xy, and 2x times z is 2xz. Okay, and we're back to where we started. And finally, let's have a look at this one. So my highest power in my x's on both of these is 1. I can divide both sides by an x, but that's the only common factor I have here. So I'm going to put an x on the front of my brackets. I'm left with an x here, and here I have a 5 because I've divided out an x on both sides. I'll just quickly show you how it works. That x to the power 1 gets cancelled out, and we're left with 1 there, and these x's cancel out completely. We're left with a 1 times 5. So there is our final answer for that one.